Okay, I am going to be measuring the inrush current from my grinder pump, and this is the circuit breaker for my grinder pump. It's a 30 amp double breaker. This is a clamp-on probe that's set up to measure peak RMS, which is going to be the inrush current, and it measures it over 80 millisecond time period. This is an amp probe, amp 310. Okay, Maureen, go ahead and run water. This will trigger when water is running, and then when it sees that when the pump is turned on, it'll measure the inrush current. Right now it's reading 0.27. I'm not quite sure where that particular number is coming from. There are two legs of power on the 240 volt pump. So what I'm going to try to do is measure it on one leg, and then measure it on another leg. And the reason I'm doing this is because this pump or motor in the eone pump is spec'd at 30 amps, no more than 30 amps of inrush. Number one, I just want to verify what the actual inrush current is. The reason is that I want to be able to run this off of a generator, and generators are spec'd for the amount of maximum current they can provide for starting a motor. They call it the surge current, but it's the same as the inrush current measurement. So, right now I'm running water upstairs, and you have to run about 8 gallons or so to go from the low level to the high level in the pump, and that will trigger the pump to run. So it could take, there we go, you see that? 30.29 is the measurement I got right there, okay? So that's one leg of power. Okay, turn off the water! Okay, the pump is running. The pump will pump down to the level. That's 30.29. So what I'm going to do is I'm going to reset it. And I'm going to set up for another one. This one I'm going to set up now for the other phase of power, which you will measure right there. And I'm going to set this up for also for the peak RMS measurement. And I just want to get the clamp on in the small gap. When it's in the small gap, that's the way to get a more accurate measurement of current. So I'm just going to try to position that so the wire falls in the small gap. That's all. Before we repeat the measurement. It's having a little trouble staying there, but I'm just going to hold it there. That's okay. And I'm a little trouble with my lighting because of the position of the camera and my headlamp. And okay, that's fine. Okay, Maureen, go ahead and run water now again.
What?
Go ahead and run the water again now. 30.29 is what we got on that one phase. That it would have pumped down whatever water was running in, and now it'll go down to the low level. We might have to add 8 gallons or so before we trigger it again. So this could take a couple of minutes of running water into the pump. Now the eone pump is spec'd for a starting wattage of 6,500, and it's spec'd for a starting current of 30 amps. And if you draw 30 amps from 240 volts, that comes out to 720 watts, which would be the wattage if you drew 30 amps straight into a resistive load. But in this case, the load is not entirely resistive. It's partially inductive, and you can draw 30 amps and dissipate less than 6,500 watts because the power factor of the load is not equal to 1. A resistive load would have a power factor of 1. The power factor of this load appears to be around 0.9, because if you use a power factor of 0.9 and you draw 30 amps, that will give you the 6,500. starting watts. I'm just verifying here whether or not my pump is meeting the spec of 30 amps in rush, which is a specification, let's say, for a new pump. Now, my pump is already several years old. It's possible in an older pump that it might actually draw more current. I don't know. This is just a way of measuring it. If you're going to be running equipment off a generator, it's always best to actually measure the load from the equipment rather than to use published values, because measured values may differ from published values. And that's a general rule. Like, for example, the wattage on your refrigerator has a certain typical power consumption. But if you actually measure the power consumption of your refrigerator using a watt meter, which you can easily get for about $20, then you will be able to know how much power your generator will need in order to run your refrigerator. And that's also true for other appliances that you have. Okay, this measurement came out at 30.52. So you can see this is a little bit over the 30 amps. And initially it said 0.2, so there are a couple of tenths here. It may not be accurate to the tenth, but this is, the other one was 30.29, this is 30.52. I could repeat this measurement a couple times and might make it more accurate, but you get the idea. It's basically drawing 30 amps, and it's a little bit over. So that's interesting, and it seems like that might be behaving a little bit normal. And the current might have gone up a little bit due to the age of the pump, but I wouldn't say there's anything wrong with the pump. That's probably just something I can put into my budget for my generator. Okay, so I just wanted to show you the setup here. Now, I could do this outside at my grinder pump panel, but I can also do it right here in my panel in the warmth of my garage. It's actually in the single digits outside right now because this is December 28th. It's probably the coldest day. Could be the coldest day for this year, possibly. We do have some danger of having some freezing grinder pumps if they're not covered with snow. But right here in Chelmsford, we do have snow cover. If you have any snow cover on your grinder pump, leave it on. If you don't have snow cover on your grinder pump for whatever reason, I would recommend to cover it with snow over the next couple of days, because we are going to hit negative temperatures in the morning over the next week, possibly going down to -7 or so. And a grinder pump which is not covered, and if the house is empty and there's no water running, you could easily freeze up your pump. Okay, that's all. Thank you very much.